This is Unit 3, Video 10, Drawing Lewis dot structures. So when we deal with Lewis dot structures, we're going to shift away from ionic bonds and shift into covalent bonds. So we're going to deal with electrons being shared. So when we deal with electrons being shared, we're going to kind of need to show where they're being shared. And when we show what's being shared, we're going to use bonds. And then we're going to need to draw where the other electrons are sitting on the atom. So this kind of gives us a 3D kind of visual understanding of maybe when things are interacting, why we get double bonds in compounds, and maybe where the compound's going to break, what's going to come in and bond in certain areas of the molecule. So the first thing we need to do when we're dealing with Lewis dot structures is we have to figure out the number of valence electrons each atom has. So when we do that, we have to look at the periodic table as kind of a cheat way for us to figure out the number of valence electrons. So if you look at everything in column 1, it's going to have 1 valence electron. Everything in column 2 is going to have 2. We're going to skip the transition metals in here. We don't really deal with those when we're doing Lewis dot structures. Column 13 is 3, 14 is 4, which we're really not going to deal much with 13, but 15 is 5, and then 6, 7, and 8. Now, the noble gases here have completed the octet, so therefore they're basically unreactive. They're happy by themselves. So what we need to do is when these atoms are coming together, these different elements, they want to complete the octet. So where one may have 3 valence electrons, it might give up its 3 valence electrons so it can complete the octet. So the first thing we need to do when drawing these Lewis dot structures is the least electronegative element is always going to go in the center. It's going to be our center atom. So if we look at dimethyl, so C2, we're going to CH2, F2, let's do this. So the least electronegative element here is going to be carbon. Now, some key notes here is hydrogen, everything wants to reach its noble gas partner. So hydrogen's noble gas partner is going to be helium. Well, helium has 2 valence electrons. So it's happy. So therefore, if it has 2 valence electrons, hydrogen's only going to form 1 bond. It's never going to take more than 1 electron, and it's going to share. So it's only going to have 1 bond, and it can only take 1 electron. So hydrogen's never going to be your center atom. Also, oxygen can be your center atom, but normally, in order to be your center atom, we're going to have to tell you that it's going to be your central atom. So for most part, whenever you see a carbon, carbon's always going to be your center atom. So here we're going to have carbon. First thing we're going to do is draw our compound out. So we've got carbon. The way we draw hydrogens is the hydrogens are going to be attached directly to what they're attached to, directly next to. So the hydrogens are directly next to the carbon, so they're going to be attached to the carbon. When we draw these molecules, we generally want to deal with stuff in 4 quadrants. So, top, bottom, left, and right. So here, it doesn't matter where you want to start at. But I'm going to start over here on the left. So I'm going to draw 1 hydrogen here, 1 hydrogen here. Now I've got 2 fluorines, so difluoro. So these are going to go up on the other 2 quadrants. So what we need to do is we need to figure out how many valence electrons do we currently have drawn on the board. So what we need to do is figure out how many electrons we have available. And that's done by adding up the valence electrons. So carbon it's in column 4 in the periodic table, so it's got 4 valence electrons, plus we've got 2 hydrogens, each has 1 valence electron, so plus 2, and each of these fluorines have 7 valence electrons. So if they've got 7, that's 14. So here we've got a total available of 20 electrons. Okay, now, because we have 20 electrons available, we need to figure out how many we drew on our picture here. So each bond that is drawn represents 2 electrons. So we drew 2, 4, 6, 8 valence electrons. 8 electrons in general. So we drew 8 electrons. So left over is 12 electrons available. So that means available to draw on our picture is 12 electrons. Now after we do available, we need to figure out the need. So the need is to complete the octet. Once we've figured out the need, we no longer look at the periodic table. We're slowly looking at our diagram on the board. So remember, everything wants to get to 8 besides hydrogen. So here, hydrogens are happy. Each of them have 1 bond. This carbon has 2, 4, 6, 8 electrons, so it doesn't need any more. This fluorine only has 1 bond, which is 2 electrons, so it needs 6 more. Okay, this fluorine also only has 2 electrons, so it also needs 6 more. So my need is 12 electrons. If your need equals your available, you draw dots. So I've got 12 dots I have to draw. I cannot draw those dots on the hydrogen. Hydrogen can't take any more. Carbon can't take any more, so they're going on the fluorine. So the fluorine needs 6 because it only has 2. So 1, 2, 3, 4, 5, 6. I just drew 6. 1, 2, 3, 4, 5, 6. That's 12. So I just drew 12 electrons, so I have no electrons left. So now we have drawn the Lewis dot structure. Now what do we do if maybe the Lewis dot structure does not equal, so that means, let's say maybe the available does not equal our need. So we do something such as, let's do HCN. So the least electronegative element is going to be carbon. So carbon's going to go in the center of the atom. Okay, hydrogen's going to go whatever's directly next to it, so it's going to be attached to the hydrogen. Okay, then on the other side, remember these molecules want to be relatively symmetrical in nature. So you don't want to draw the nitrogen up here. We want to make things pretty symmetrical. So we're going to draw an N over here. Now we need to figure out available. So let's figure out the number of valence electrons. So carbon has 4 valence electrons, plus hydrogen, which has 1, plus nitrogen, which is going to have 5. So we've got a total of 10 electrons. But we drew 2, 4. So we drew 6 electrons. So if we drew, we drew 4 electrons, not 6. We drew 4 electrons, so therefore we have 6 electrons available to draw. Okay, but we need to figure out how many do we need to complete the octet. So now we need to do our need. Okay, well this hydrogen doesn't need any more. This carbon has 2, 4, so it needs 4 more electrons to complete the octet. This nitrogen has 2 electrons, so therefore it needs 6 more electrons to complete the octet. So my need is 10 electrons. If our need does not equal our available, we make up the difference with bonds. Okay, so I need 4 more electrons. Each bond is 2 electrons. So if I need 4 electrons, I need to draw 2 bonds. I can't draw that bond here because hydrogen can't take another bond. The only place I can draw these bonds are here between the carbon and the nitrogen. Every time I draw in my structure, I have to go back to my available and cancel it out. So I just drew 4 electrons. So the electrons I have left are 2 electrons. Now, once I've drawn the bonds, I can draw the dots. So I'm going to come back and complete the octet. So carbon can't take anymore. Carbon has 2, 4, 6, 8. Nitrogen only has 2, 4, 6. So therefore it needs 2 more electrons. And now we've completed the Lewis dot structure. So in summary, you need to first figure out the number of valence electrons, which gives you the available electrons needed to draw. Then you need to figure out how many you need to complete the octet. If available does not equal need, you have to make up the difference with bonds.